Hey guys, let's just finish up these last two examples in the 3.1 notes. Again, we've done everything else already, but we'll just finish these last two. So again, we've been talking about extrema on a closed interval. The extreme value theorem says that if we have a continuous function on a closed interval, then there must be an absolute max and an absolute min in there. The other thing that we talked about was that the only places that where that max or min could occur is at an extrema, and extrema are places where the derivative is either 0 or undefined. And those are the only places that the max and min can occur. All right, so we had this list right here of how to find the extrema. So the first thing you had to do was find the critical numbers. And that, again, that was from taking the derivative and set it equal to 0. Then evaluate f at each of the critical numbers, and then evaluate f also at the two endpoints, and then you pick the highest one to be the max and the lowest one to be the min. All right, we did example 2 already, and so we're going to do examples 3 and 4. All right, so find the extrema of 2x minus 3x to the 2/3 on the interval -1 to +3. So again, the first thing that we do is we should be checking to make sure that we have a continuous function on a closed interval. So the closed interval is obvious. We just have to make sure that this is continuous. So this part is continuous. And then this is asking us to take the cube root of something and then square it. We are allowed to take the cube root of any number, and then when we square it, it's still fine. So this is also continuous, therefore their difference is continuous. All right, so in order to find the extrema on the closed interval, the first thing we do is we take the derivative. All right, hopefully you can do that. If you want, stop the video and do it and then come back. Okay, if we do that, we end up with 2 minus, we're going to bring that 2/3 down and multiply it by the 3, so we get minus 2 times x to the -1/3. For our purposes, I am going to rewrite this. I feel like anytime I have a negative exponent, it helps give me a little bit more intuition if I see it in its proper place. So I'm going to write this as 2 minus 2 over x to the 1/3. All right, so now I'm looking for where is this 0 or where is it undefined. All right, so the second, so this again still is all part of the first step. So where is this 0? In other words, where is 2 equal to 2 over x to the 1/3? So again, if we want this equal to 0, it gives us that equation, 2 equals 2 over x to the 1/3. If you don't believe me, set it equal to 0 and then you'll get to that step. Okay, then here I'm going to cross multiply and I get 2x to the 1/3 equals 2. And then I'm going to divide by 2, so I get x to the 1/3 equals 1. In other words, the cube root of which number equals 1, so x equals 1. That's one critical value. All right, the second possible way we're going to get a critical value is if we find out where this is undefined. And that is undefined when x equals 0. All right, so our second critical number is at x equals 0. All right, again, we're just looking for where the denominator is 0, and that will give it to us. So this came from getting the derivative equal to 0. This came from finding when the function is undefined. Okay, so then the second step says evaluate the function at each critical number in the closed interval. All right, so I'm going to make a table here. So our x value is going to be 1 and 0. I'm also going to add the x values that represent the endpoint. So I'm going to have -1 and +3. And then I just want to find out what the y value is that goes along with it. So again, it says to evaluate f at each of these points. I put it back in the original equation. So 2 times 1 is 2, minus 3 times 1 to the 2/3. 1 to the 2/3 means take the cube root of 1 and then square it, so that's just going to be 1. So 2 minus 3, negative 1. I plug in 0. Hopefully you can see easily I get 0. I plug in negative 1. Here I'm going to get negative 2. And then when I take the cube root of negative 1, I get negative 1. When I square negative 1, I get positive 1. When I multiply that by 3, I get 3. So it's negative 2 minus 3, which is negative 5. And then I put in 3. So 2 times 3 is going to give me 6. The cube root of 3 squared, so it's going to be the cube root of 9 times 3. That's kind of gross. Sorry, I didn't realize I was so close to the end of the page there. If I put that into my calculator, I end up getting negative 0.24. Roughly. All right. So then we have to pick the least of these values to be the minimum. That means that we're going to have this as the min. So the absolute min on negative 1, 3 is, you can either say at the point negative 1, negative 5, or you could say is negative 5. Again, we can either give the whole ordered pair or we can give the y value. All right, the second one is to find the max, all right? And interestingly, 0 is the max. Everything else is negative. So absolute max on negative 3, I'm sorry, negative 1, 3 is at 0, 0. Okay, this last example is going to test all of our patience. Because it's a trig and it's a complicated trig one, so make sure you ask me if you have questions. All right, so again, we want to make sure that it's continuous on the closed interval. Again, that's obvious that it's closed. Is this continuous? Well, hopefully you can answer that sine is continuous everywhere, cosine is continuous everywhere, so their difference is continuous everywhere. So yes, it's continuous on this closed interval. All right, so to find extrema on a closed interval, again, we're going to go through those 4 steps. The first one is find the critical numbers. So we do that by finding the derivative. All right, so we're going to get 2 cosine x is the derivative of this. Here we're going to have to use the chain rule because this is not just a plain old x. So cosine is our outer function and 2x is our inner function. So minus the derivative of the outer function, which is negative sine. We leave the inner function alone, and then we take the derivative of the inner function. All right, so let me just clean that up a little bit. So we end up with 2 cosine x plus 2 sine 2x. And we want to know where this is 0 or undefined. So again, with the same logic as we did up here, this is not going to be undefined anywhere because both of these are continuous. All right, if it were secant or tangent or something like that, yeah, we would run into some problems. But here we'll just be looking for where this is equal to 0. Now, perhaps you're a little bit concerned about this 2x right here because our arguments are different. Here we have an x, here we have a 2x. So again, if you look at those pages, either at the very beginning or the very back of your calc book, there's a list of all the trig formulas. So you should see a double angle formula there that we can replace this with so we get it down to a single angle. So if we do that, we end up with 2 cosine x plus 2. Right, the double angle formula that we're going to substitute this for is 2 sine x cosine x. So if we clean that up again, we're going to get 2 cosine x plus 4 sine x cosine x, and we want to know when this equals 0. All right, so this goes back to when you worked on solving conditional equations in Trig. In order to get something like this equal to 0, we're going to try and factor this side. So I can see that I can take out a 2 cosine x, and what I'm left with is 1 plus 2 sine x. And that is equal to 0. All right, I have a product of two things equaling 0, so one of them has to be 0. So either 2 cosine x equals 0, or 1 plus 2 sine x equals 0. All right, the 2 does nothing here, so really we're looking at when is cosine equal to 0. That occurs at pi over 2 and 3 pi over 2. This one's going to require a little bit more work. We need to get the sine by itself, so we're going to bring the 1 over and then divide by 2. So we're going to get sine x equals negative 1/2. All right, so we know a couple things here. One is it's negative. Sine is negative. If you remember, all students take calculus. Hopefully you learned that mnemonic last year. All 4 trig functions are positive here. Only sine and its reciprocal cosecant are positive here. So it can't be in the first or second quadrant because then it would be positive. That means it has to be in the third or fourth. So in quadrant 3, we're going to get a value for x. And then in quadrant 4, we're going to get a value for x. All right, so then we have to think, well, when is sine equal to 1/2, either positive or negative? What angle? And you should remember that is a 30-degree angle or a pi over 6. So we're looking for the pi over 6 angle that's in quadrant 3 and the pi over 6 angle that's in quadrant 4. Again, this is 6 pi over 6. So the one in this quadrant right here would be 7 pi over 6. This is 12 pi over 6, so the one going backwards in quadrant 4 would be 11 pi over 6. All right, so our critical numbers are, I'm just going to write Cn, are pi over 2, 7 pi over 6, if I'm putting them in order, 3 pi over 2, and 11 pi over 6. All right, so now into step 2. That was a lot of work just for that step 1. In step 2, we're going to take and make a table of when we have x being these 4 values, what's the y value that we get out, and we have to include the 2 endpoints, so 0 and 2 pi. So let me make a chart here. So here's our x, and here's f of x, and I'm just going to go in order. So 0, pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. All right, again, these are our endpoints, and these are the critical values. All right, so we just have to plug them back into the original equation. So this is asking us to do 2 times sine of 0 minus cosine of 2 times 0. So again, cosine of 0. All right, 2 times sine of 0, that's 0. And then cosine of 0 is 1. So this ends up being negative 1. Right, if we plug in pi over 2, that's 2 sine pi over 2 minus cosine of 2 times pi over 2, so just pi. All right, again, this is also 1, but now since it's on the negative x-axis, it's negative 1, so we're going to end up with a plus 1 for this part. Sine of pi over 2 is 1 times 2. All right, so we should get 3 here. All right, 2 times sine of 7 pi over 6 minus cosine of 2 times 7 pi over 6. Again, we just did this one. This is a half, but since it's in quadrant 3, it's going to be negative 1/2 times 2 is going to be negative 1. All right, these will cancel, and we're actually being asked to find 7 pi over 3. That goes beyond our 2 pi, because again, 6 pi over 3 would be 2 pi. So this is pi over 3, but in the first quadrant, because we've gone all the way around and we're back up in here. All right, cosine of pi over 3 is 1/2. So this is minus 1/2. So this is negative 3/2. All right, let's do the same thing here. We've got 2 sine 3 pi over 2 minus cosine of 2 times 3 pi over 2. That's the same as cosine of 3 pi. Sine of 3 pi over 2 is negative 1 times 2 is negative 2. Cosine of 3 pi, again, that took us pi, 2 pi, 3 pi. We're back here, so that's negative 1. So minus a negative 1 is going to be plus 1, should give us negative 1. Yep, that's what I have. I'm looking at my answers to make sure I'm not screwing up here. This is 2 times sine of 11 pi over 6 minus cosine of 2 times 11 pi over 6. The 2 and the 6 are going to cancel out, so this is going to be 11 pi over 3. Sorry, I didn't realize that was... Oh my goodness, I'm so sorry. All right, I'm just going to pause there for a second for you to copy what I have written there. Okay. You can always pause and just look at that screen. Okay, this is in the fourth quadrant. We know pi over 6's for sine are 1/2, but it's in the fourth quadrant, so it's negative. So this is negative 1. 2 times negative 1/2. Right, 11 pi over 3. So 6 pi over 3 would be here. Let's see, this is pi, 2 pi, 3 pi. That would give us 9 pi over 3. 4 pi would be 12 pi over 3. So we don't quite make it. All right, 11 pi over 3 would be in the fourth quadrant. Cosine is positive there, and it's 1/2. So this is minus 1/2. All right, so we end up with minus 3/2. All right, and then finally, a nice easy one, 2 sine 2 pi minus cosine of 2 times 2 pi. All right, this right here gives us 0, so we end up with 0. Cosine of 4 pi, this is going to be 1, so minus 1, and we get negative 1. Okay, I'm out of space, so we're just going to have to kind of squish it in here. All right, so we're looking for the max. We're looking for the min. So the max occurs right here. Right, that's the highest value. And then the min occurs, actually there are 2 mins. One is right here at 11 pi over 6, and the other is at 7 pi over 6. All right, so max is at pi over 2, comma 3. And the min is at 7 pi over 6, comma, negative 3/2, and 11 pi over 6, negative 3/2. Yeah, negative 3/2. The trig was beastly there, but again, the 4 steps are the same. So we find the derivative, set it equal to 0 to get the critical numbers, also figure out where it's undefined, not relevant here, then put all of those values along with the 2 endpoints into this table and fill it in. This was the part that was really a pain in the neck. And then the highest one is the max, and then the lowest ones are the min. Okay, that's it.